All right, thank you everyone for joining today. Looks like we have everyone that was able to make it in. My name is David Waltzman, and I lead up the sales effort here at UberCloud. Today, I'm joined by Avery Tylak, our marketing manager here at UberCloud. The topic for today is going to be ANSYS on Azure. UberCloud is an excellent partnership with ANSYS. We're an advanced solutions partner and really enjoy all the progress that's happening with the cloud and our companies collaborating together. So with that, I'd like to hand it off to Abru for the presentation.
Thank you, David, and thanks everyone for joining our webinar today. So as the title of my slide indicates, the world of HPC has changed. So before, HPC was available only on-premise clusters, and these required expensive hardware and were expensive to operate. And not all scientists, all engineers could get access to HPC. Lack of resources held them back from innovation. But the world of HPC has changed. So today, engineering expertise is expensive. There's huge demand for the expertise, but there are not so many skilled engineers to fulfill the demand. And companies, they can't afford to waste their engineers' time sitting and waiting for their simulations to finish. So to stay in business, they need their engineers to be highly productive and to innovate. So on the other hand, computational power in the cloud has become cheaper than ever. Now, engineers, they can efficiently use their time running more simulations faster. For under $1 an hour, you can get access to powerful CPUs, GPUs that accelerate simulations by many fold. So take a look at the chart here. Here we compared the total cost of ownership of HPC in the cloud for 1 year to the cost of ownership of an in-house cluster. And this study was done by taking a 20% utilization of a 256-core in-house system as basis. And we found out cost of simulation in the cloud is more than 72% cheaper compared to an in-house system. And technology is moving fast too, so IT, they can't keep up with the latest technological developments with the new GPUs, InfiniBand, and all the other advancements. And you don't want to miss out on the latest tech that will speed up your simulations. So as a result, at UberCloud, every day we see more and more engineers coming to us. So they ask us to take their simulations to the cloud. Today, we witness amazing new studies happen because best-in-line computational resources are finally accessible by everyone, by engineers, by scientists, and we help them speed up their simulations and to innovate. So I will tell you a story about this. A researcher from Stanford University, Francisco, he did not have the compute power he needed to run his analysis. And he was ready to make scientific breakthrough, but unfortunately, lack of resources were holding him back. And I will get back to this in a few minutes. So first, if you're here attending this webinar today, whether you're a CAE engineer or IT, it means you already use ANSYS or support ANSYS on-premise workstations or clusters, and you're facing some challenges. So in today's world, product design is driven by simulation, which means lots of simulations need to be completed to finalize a design. And as an engineer working with outdated, slow machines, you have to make trade-offs, simplify your models to run them faster so that you can run more simulations in a shorter time period and bring products to market faster. And in addition to compute time, accessibility is another challenge you face. It is difficult to work on premise servers. Accessing, manipulating 3D models is very difficult without the latest technology. And engineers end up transferring large amounts of data every time they want to check the progress of their simulation. This takes lots of time and makes their life harder. So on the other hand, for IT, total cost of ownership to operate an HPC cluster is very high. So the deployment, maintenance, support of HPC is a huge challenge. And as this requires specialized, dedicated staff to handle the various requirements of HPC applications. Deployment of new hardware, software can take weeks and requires intensive work. So running ANSYS on Microsoft Azure HPC Cloud provides many exciting opportunities to overcome all of these challenges. So let's take a look at what Azure has to offer, and then I want to talk about how you can take your ANSYS simulations to the cloud and its benefits. So first of all, by taking your simulations to Azure, you will no longer be responsible for hardware purchase and maintenance. You'll be leasing the resources on an as-needed basis, and getting access to short-term specialized hardware and software resources will save you lots of money. And don't worry about not having the staff or the experience to set up your HPC applications on Azure. A cloud partner such as UberCloud will help make your transformation to the cloud seamless. UberCloud is an ANSYS advanced solution partner and brings this expertise to Azure. So whether it's Fluent, CFX, Mechanical, HFSS, or Discovery Live, through a trusted cloud partner, you can get it all set up and running within hours, if not minutes, on your cloud compute environment. And Microsoft has created a set of capabilities for high-performance computing, including servers, high-speed networking, and storage suited for CAE workloads from multiple disciplines. And you can boost the performance of your ANSYS jobs by using the specialized hardware that meets the requirements of your specific simulation. Azure offers InfiniBand, and it is important to mention that this is not available on many other public clouds. With the HPC-grade high bandwidth, low latency network, your parallel workloads will scale much more efficiently. And through Azure, you'll also get access to the latest CPUs from Intel, as well as NVIDIA GPUs used in parallel computing to accelerate calculations, but also increase the performance of graphics rendering for 3D models. And actually, there was this news recently, you might have heard of it. Currently, there is a shortage on NVIDIA GPUs due to huge demand for Bitcoin mining, which is viral around the world right now. But you don't have to worry. Azure has plenty of GPUs to cover all your needs. So we talked about all the awesome things Azure has to offer, and now let's take a look at an example on how ANSYS performs on Azure. So this is a benchmark study for the transonic flow around an airfoil, and it's an ANSYS model with over 100 million elements. So it's a great demonstration of how cloud HPC can speed up your simulations. So on top, you see here how the model nicely scales up from a small number of cores on one node going to large number of cores, up to 512 cores on 32 nodes. So here, the higher the solver rating, it means the better is the scaling. Now look at the bottom chart for the same problem. We compared simulation runtimes on a 2-year-old on-premise cluster, which was up to date with the latest technology at the time of purchase, and the runtimes on an UberCloud Azure environment. So both with the same number of cores. And you see here, UberCloud Azure environment performed 53% faster compared to the on-premise cluster. And this is a great example that shows you how quickly your on-premise cluster can get outdated compared to the latest hardware that's available. So next important thing I would like to mention about running ANSYS simulations on Azure is that you can pick up the licensing that matches your specific needs. So for a job that scales up well, ANSYS elastic licensing model helps significantly reduce the job cost as you add in more cores. ANSYS offers two types of licenses to run HPC jobs on the cloud. You can bring your own licenses, meaning using your existing licenses and then use additional elastic licenses for running multi-core HPC jobs. And the other option is to use standalone elastic licensing, which means pay for what you use. So independent of whether you bring your own license or use elastic licenses, for running ANSYS HPC jobs on multiple cores, you will always need additional HPC packs. And here's an example scenario where a large model with calculation time of 13 days on 4 cores is used as basis. So on top here, you see this example problem has a nice speed up and scales up pretty good as the number of cores increase. And the simulation time drops significantly to less than 1 day. So which means you will actually end up utilizing the cloud resources for a shorter time duration. On the bottom, we compare the cost of running these jobs on different number of cores in the cloud. So prices include high performance computing hardware on Azure, UberCloud license service, and additional license costs for Fluent and HPC packs. So between running simulations on 12 versus 32 versus 128 cores, each time I just had to add in one additional HPC pack to run the multi-core analysis. So each HPC pack unlocks computing on a very large number of cores, and you might want to take advantage of this feature. The most important thing to see here is that for a simulation that scales up well, due to simulation times getting shorter on more number of cores, and the way ANSYS licensing works, the price gets cheaper as you add in more cores. So with ANSYS licensing model, you can reduce your costs significantly while running your simulations much faster. So, we saw that running ANSYS simulations on Azure enables you to significantly boost up your simulation performance while running costs. But in addition to all of these, simulation in the cloud provides a pleasure-to-use experience. And let me show you how. So as an example, let's take a look at the UberCloud Experience. So once you sign up, you receive a welcome email with your login information. And now all you need is a web browser and an internet connection. I click on the link, enter my password, and I'm in the cloud. It's that simple. So here you see an UberCloud compute environment set up on Azure. And as you see, it just looks like your regular desktop. Here on my screen, I have ANSYS Discovery Live open. And Discovery Live is a true game changer for product design and development. It can provide you with real-time results while you're still designing and editing your model. And because it requires a new NVIDIA graphics GPU to perform the calculations and provide high-quality visualizations in real time, this makes it actually a perfect fit for running on Azure. So best thing about running in a cloud environment is that you don't have to change your existing workflow. There's no new tool to learn. You can continue doing whatever you were doing before on your own workstation. So you can work through a graphical user interface for pre-processing, post-processing, and submitting jobs. So only with one difference, you'll be doing all of this in the cloud. So I'm going to show you a screen recording on the UberCloud environment. You'll see the whole experience for yourself. So this is a short demo on ANSYS Discovery Live and about getting results in real time. So the performance, the visualizations here you see can easily make you think that you have this whole thing running on your local workstation. Simply amazing. So I remember actually back in the day, it was nearly impossible to remotely do any pre-processing or view results. So there was even a time I drove all the way to work at 10 p.m. at night to review my results so that I could submit jobs overnight. But today, thanks to advancements with GPUs and remote visualization technology, you can view your results from anywhere, anytime, which is an amazing benefit for engineers. So as a summary, there are huge benefits for engineers for running ANSYS simulations on the Azure HPC Cloud. So first, you don't have to do trade-offs anymore. Thanks to the hardware configurations based on your needs, you can run simulations fast while using more detailed models that capture the realistic behavior accurately, and you can have confidence in your design. And then with a dedicated cloud HPC cluster, you can add in more compute power instantly as you need and bring your products faster to market. So cloud has also global accessibility. It can be accessed from anywhere to run jobs, post-process results. Even your colleagues overseas can utilize your licenses when you're not using them. They can even access your compute environment, review results, helping for better collaboration. And last but not least, unlimited hardware means you can actually run multiple analyses in parallel, do design optimizations, use new codes, and unlock any new capabilities based on your needs. So there are also great benefits for IT. So in addition to the significant cost savings, simulation in the cloud takes off workload from IT. Initial setup, software maintenance for ANSYS upgrades, ongoing operations such as adding, removing nodes, support for break-fix services, training on how to use the services. These will all be offloaded from your IT. And all these services will be provided by your trusted cloud provider, such as UberCloud. So we talked about benefits, and now let's take a look at some examples. Once you take your ANSYS simulations to the cloud, we make sure you will get consistent, reproducible results. UberCloud has conducted many case studies and experiments within different disciplines. Life sciences, aerospace, automotive are only a few to name. And these were all done to prove the ability to set up and run simulations in the cloud fast while getting accurate, consistent, reproducible results. So for these studies, we partnered with engineers, scientists worldwide, all experts within their disciplines. And today we have more than 4,000 community members and over 200 case studies. So remember, I was telling you about this researcher from Stanford University, Francisco. He's actually one of these scientists we partnered with. So he didn't have enough compute power for his research, and UberCloud provided him with a 160-core cluster in the cloud so that he could complete his breakthrough research on realistic virtual human heart simulations. And with the compute power provided, he was able to complete his award-winning study and publish it. So Francisco told us this project may not have happened if he didn't have the compute capacity he needed. So you can get access to this and many other case studies for different simulation software and disciplines on our website. So just look under resources. And now let's take a look at some of these examples. So this one here is an experiment to better understand the airbag inflation under dynamic conditions. And simulations were performed with ANSYS LS-DYNA for different mesh densities to capture the accurate behavior of the airbag unfolding and stresses in the airbag material. So the team was able to capture accurate results and fast solution times based on efficient use of Azure resources. And the finer the mesh, the more accurate the simulation results were, but longer runtimes were observed. So on left, we see how solution time increases on one core, going from 4,000 elements to 132,000 elements. And on the right, we see that using 32 cores, we can complete this the simulation for the model with 132,000 elements within under 30 minutes. So here's another study. This is for the modeling of airflow through an engine intake manifold. And one thing to note here is that you don't have to have very large models to run them in the cloud. You can basically take any simulation to the cloud and benefit from utilizing additional resources as you need them. The design of the intake manifold is one of the key factors determining engine performance. So this was an interesting study. And here, in addition to running simulations in the cloud, also pre-processing, post-processing were done in the cloud environment with ANSYS Workbench and Fluent. And here we see simulations for different mesh densities and how the solution time drastically reduces going from one core to multiple cores. And final model with the smallest mesh size was completed in around 5 minutes here. Final example I'm going to show you is for the aerodynamics and fluttering study of an aircraft wing. So the CFD models were generated in the ANSYS environment with ANSYS Workbench, which made the process of model generation easier and reduced process times drastically. And let's take a look at simulation runtimes, starting with a coarse mesh of 750,000 elements, all the way to 12 million elements. Again, here we see by using the HPC resources in the cloud efficiently, the very fine mesh model was completed under 2.5 hours on 32 cores. So I would like to stop here and give David a chance to make the final remarks. If you want to learn more about this case study or any other case studies, just feel free to check out the papers on our website. And David?
Thank you, Ebru. And so Ebru spoke about several different solutions today. One was ANSYS Discovery Live. This is new for most of the people out there. And so what we're offering right now is a proof of concept. It's for 5 days. We have all the best NVIDIA GPUs and Intel CPUs ready to go. ANSYS Discovery would be installed and ready, just over $1,000. Again, a great way just to get out there and get familiar with the technology before making further investments. Can you go to the next slide, please? This second option is an ANSYS mini cluster. So for those of you that are more interested in the scaling capabilities that Ebru walked through in the different case studies, this would give you a taste of what's possible in the cloud. So with this mini cluster proof of concept, we're looking at 64 cores, again, latest generation Intel Xeon, 448 gigs of RAM, and a 2 terabyte solid state drive. So an excellent system. This is the de facto one that I usually configure with clients. Then we have full ANSYS GUI installed and ready. This test would be for 5 days as well, just under $1,500. A great way to get your feet wet without going through all the IT headache of setting up a cluster and configuring and transferring your own licenses, just right out of the box here. Next slide, please. All right, so if any of this interests you, the best way to get in contact with our sales team is to email us at sales@theubercloud.com. You can also visit our website, www.theubercloud.com. There's lots of great information for the different case studies that Ebru discussed, as well as contact forms where we can set up a consultation and see what system would be best for you. So that concludes the content for today, but we had several questions. So I'm going to address those now. If you've saved up your questions, this is the time to enter them in the chat, so don't hold back. The first question we had was asking if the charts will be available. Yes, a recording of the session as well as a PDF of the presentation will be available afterwards.